The blade of a circular saw is initially at rest, which is what I've written down here. So the initial angular velocity is going to be 0. The power switch is then turned on, causing the blade to accelerate at 2.5 radians per second squared. So the angular acceleration is going to be 2.5 radians per second squared to 125 revolutions per minute. Because we have a displacement unit over a time unit, that tells us that it is angular velocity, but that we need to convert the units. So this is going to be the final angular velocity, and I've written revolutions over minutes. I'm first converting the revolutions to radians, so you'll notice here that the revolutions cancel out top and bottom, so I'm left with units of radians. And then I'm converting the time units because it needs to go from minutes to seconds. So notice I've written minutes up here, so I can cancel this minutes here, so I'm left with units of seconds. So my final angular velocity turns out to be 13.1 radians per second. I am first asked, how long does this take? So how long does it take to go from 0 to 13.1 radians per second? So I need to solve for time. I go to my list of kinematic equations, and the first one is this equation here. And I have final velocity, initial velocity, and acceleration, so I can solve for time. So I plugged my numbers in here and solve for time. It also asks me how many radians does a blade rotate through. Because I now have time, I can actually use any of the kinematic equations that have angular displacement in it to solve for angular displacement. So I chose equation 2 because it's already solved for angular displacement. My initial angular velocity is 0, and anything times 0 is 0, so this term here becomes 0. I plugged in my angular acceleration, and I plugged in the time I found in part A in order to solve for the angular displacement. And you notice here that the units are radians.